We've dealt a lot with polynomials, and now we're going to move on to radicals. So we've dealt with what to do if our power is, 2, 3, 4, 5. But what if we have square roots or cube roots or fourth roots or things like that? So that's what radicals is about. So the first thing to tell you when you're solving radicals is that you want to get the radical, that's the square root or the cube root or whatever, by itself as much as possible. So right now it is by itself. This square root is completely by itself on the left side. So to get rid of that square root, I simply square both sides. Because the square root, the opposite of it is squaring. So that square root will be canceled out by the square, and you're left with 6x minus 2 equals, and then 2 squared is 4. Add 2 to both sides, and divide both sides by 6. Now one thing you want to do is make sure your answer works, because you cannot take the square root of negative numbers. So it's good to double check. Take this x equals 1, and I'm going to plug it back in the square root part. And I get 6 minus 2, which is 4, so that's all good. No problem. You just want to make sure you don't get a negative when you plug it back in. So our answer is x equals 1. Okay, next example, square root of 2x plus 3 minus 5 equals 0. Again, you want to get the square root by itself. So I don't want that minus 5 with it, or it'll really make the problem complex. So I'm going to add 5 to both sides. And now I can take this, I can square both sides, because I want to get rid of the square root, so I square both sides. So square root of 2x plus 3 squared gives you 2x plus 3. 5 squared is 25. I subtract 3 from both sides, and I get 2x equals 22. Divide by 2, and I get x equals 11. Okay, now it's up to you if you want to write it out or just spot check. So I want to plug 11 back in here just to make sure. 2 times 11 plus 3. That's 22 plus 3, and you can tell already it's going to be positive. You don't really need to know what it equals. You just need to make sure it's not going to be negative. So you can take that as far as you need to. So x equals 11 does work. Okay? X equals 5 square root of x. Now this one I'm going to do two different ways just so you can see it both ways. It's up to you if you want to leave the 5 with the square root or if you want to move it over. Personally, I would probably leave it where it is. It's more so the adding and subtracting you want to make sure isn't with the square root than the multiplying or dividing. So I'm going to leave it this time and then square both sides. So x squared is just x squared. Now make sure you square everything. So I have to square 5 and get 25. And square root of x squared is just x because it cancels out the square root. Okay, then this should look like what we did before with polynomials, where we're going to need to factor. So subtract 25x from both sides and say, okay, what do these two have in common? Well, they have an x in common. So then I can set both of these equal to 0. X equals 0, x minus 25 equals 0, and that gives me x equals 0, and if you add the 25 over, it gives you x equals 25. So again, just spot check that. See, can you plug in 0 here? Sure, square root of 0 is 0. Can you plug in 25? Sure, you just can't plug in a negative. So both of those answers do work. And there you go. Now you can get the same result if you do move the 5 over. So let's say back here at the beginning I decided to divide both sides by 5. It would have given me x over 5 equals the square root of x. Then I could square both sides. I'd get x squared over 25, because you have to square both pieces, equals x. So the easiest thing right now is probably to multiply both sides by 25, in which case you end up in the exact same place we were here. So you can see that you can get the same thing either way. If it helps you to just go ahead and move that 5 over so the square root is completely by itself, that's your call. But you'll get the same result either way. Alright, x equals the square root of x plus 2. I have to square both sides. The square root's already by itself. So I get x squared equals x plus 2. Again, you've got two different x's showing up with different powers, so I need to Move them all over to one side, so it's set equal to 0, and then factor. So I get x minus 2 and x plus 1. So x minus 2 equals 0, and x plus 1 equals 0. Then we get x equals 2, and x equals negative 1. Okay, so just double check. If I plug 2 back in here, 2 plus 2 is positive 4, so that's no problem. Negative 1 plus 2 is positive 1. So this is a good spot to make this clear. Your x value can be negative. It's not necessarily a problem that we have x equals negative 1. It's just that when we plug in that negative 1, it can't give us a negative inside the square root. So in other words, when I plug in negative 1, I end up with positive 1, so it's okay. You can have x equals a negative, you just can't have the square root of a negative. Okay, so this one, again, the square root's all by itself. That's one thing you want to make sure of. The square root must be by itself as much as possible. And then we square both sides. So this side just cancels out the square root, leaves us with this. Okay, this is a huge mistake that people make very commonly, and I want to try to warn you against ever doing it. You cannot just square both pieces inside and say x squared plus 1, because x squared is x squared and 1 squared is 1. That does not work. You cannot do that. You have to think, what does squared really mean? Okay, squared means times itself. So this is really x plus 1 times x plus 1, because squared means you multiply the thing by itself. So that means you have to FOIL. So you end up with x squared plus 2x plus 1 when you do that. So please make sure you don't just square the two pieces inside. If you're adding or subtracting, you've got to FOIL. Alright, so I'm just going to move everything over to the right side. Doesn't matter which side you choose. Actually, I'm not going to move everything over now that I look at it again. So the x squareds cancel each other out. Now I get negative 2x plus 3 equals 2x plus 1. So I'm going to subtract 2x from both sides. That gives me negative 4x plus 3 equals 1. So then subtract 3 from both sides. And I get negative 4x equals negative 2. Divide both sides by negative 4. So I get x equals 1/2. X equals 1/2. And if you do try to plug that 1/2 back into the square root up top, you will get a positive answer, which is good. You just want to make sure you don't get a negative one, so x equals 1/2 will work. So hopefully you've noticed sometimes you end up with one answer, sometimes you end up with two, and either way you need to check them and make sure they don't give you something that's negative in the square root. Okay, last example here. This could be written another way. I could write it like this. It's up to you which way it is written, or they may write it either way when it comes to a problem. But raised to the 1/3 means the same thing as a cube root. Just like raised to the 1/2 means the same thing as a square root. So just like we get rid of a square root by squaring it, we'll get rid of a cube root by cubing it. So I cube both sides. The cube gets rid of the 1/3, or the cube root, just leaving x minus 4, and 2 cubed is 8. So my last step is just to add 4 to both sides, and I get x equals 12. Now just so you know, if it is an odd root, cube root, 5th root, 7th root, you don't have to go back and check those, because you can do negatives with that. You can do a cube root of a negative, or a 5th root of a negative, or a 7th root of a negative. It's the even roots you can't do negatives with. You cannot do square root of a negative, 4th root of a negative, 6th root of a negative, and so on. So just be aware, anytime it's an even root, square root, 4th root, and so on, you do need to check your answer to make sure it works. With cube roots and 5th roots, you don't have to worry about it.